Grade 8, let's look at the revision that we have. This is revision 1. Shall look at question number 1 as we go on. Anyway, what do we expect in our paper or paper 2? Our first expectations are here. As we revise, we shall expect to look at the following and put them in plan. Revision 1, what we expect to see. Our question 1. Our question 1 is going to be a multiple choice. Our question 1, it's a multiple choice. We need to circle the right answers. Then when you look at question 2, we shall expect to look at what we call whole numbers. Whole numbers. We shall look at whole numbers and integers. Then question number 3. Question 3, we shall look at common fractions. Question number 3, we shall expect to see common fractions and decimals or decimal fractions. Decimal fractions. We look at question number 4. We shall look at exponents. Exponents. Here we shall expect you to know the rules and where they apply. Then question number 5. Question number 5, we shall look at number patterns, number and geometric patterns. Then question 6. Question 6, we shall look at functions. And relationships. Functions and relationships. Finally, we shall look at question number 7, which looks at algebraic expressions. We shall look at algebraic expressions. So this is what we expect to see in our paper, which could be out of 60. And you'll be sitting for 1.5 hours. All right, let's look at the first revision here. We see how multiple choice could be. Here they're asking us, or they're telling us, question number 1, multiple choice questions. For each of the questions below, 1.1 to 1.10, 4 possible answers are given. Choose the correct letter A to D that matches with the correct answer. E.g., 1.12, if it's D, you write D. Then you will read those instructions very carefully. If they say circle, please circle. If they say give the number 2, put the letter next to the number, do that. All right, let's look at the first question here. Now here we expect you, because it's 1 mark, we expect you to use your calculators as grade 8. Then your calculator has to come up. All right, the question says 1.1. What could be the answer? They're saying the square root of 0.0025 equals, so come in your calculator, press this, press the number there, equals to 1. Now, this is a fraction. Here there are no fractions. They're all decimals. Press the SD, and our answer here becomes C. Our answer here becomes C. Okay, we look at this next question there. Remember, we're doing revision. So 1.2, it asks us for the highest common factor. Highest common factor, so all you do is to write down 120 and 240. What are the factors? What are the factors of 120? We have 1 and 120. Also here we have 1 and 240. Then we have 2. Also here we have 2. We have, okay, 2 goes with what? 60. 2 goes with what here? It goes to with 120. Then we look at 3. 3 is a factor of 120, whereby it goes in 40 times. 3 is here, it goes how many times? 8 with 3. And then we continue. But so far we can stop here because we see this is the one. And also we have it here. So the highest factor here is what? 120. 120. A factor, a number that divides another and don't get a remainder. Okay, so our answer here is what? B. We look at these values here. Simply meaning this is the same as 4 times 5. You get your answer as 20. Whereas here you have 12 plus 8. Oh, also gives you what? 20. So which rule is this? It's going to be C, distributive. They distributed, the 4 has distributed with 3, at the same time it's distributing with, when you look at it here. So it's distributive. Then this one you can't use a calculator. 1.4, we shall pull out our calculator again, because I'm using a calculator because it's 1 mark. So what does it want us to do? We have to get a cube root of 27 over 64, push using this arrow here, times, open brackets, put this simple there, 4 out of 5, close brackets, to the power of 2. What is the answer? 12, comma. So here our answer is D. Then the number 0,000125 in scientific notation is equal to, scientific notation, remember, you're moving from the left-hand side going to the right. What comes in your head? I am going to the right. It has to be a negative answer. So now the answer here has become 1,2 times 10 to the power negative. How many times have you moved? 1, 2, 3, 4. So negative 4. Is there any answer that looks like this? Yes. It's what? It's D. Okay. We come back. Let me see if our calculator will give us this answer here. It's 0,000125. If I press equals, yeah, the calculator gives me the answer there. So it's fine, straightforward. Okay, we come to this and we see decrease 80% or 80% decrease by 25%. This is so simple. You get 80% minus 25 over 100 times 80. I'm here looking at this. Oh, when you put this in your calculator, you get 20. But if you don't want to get disturbed, you just get 8 minus, open your bracket, 25 over 100 times 80. The reason why I'm doing this is because I'm reducing. So to avoid confusion, That's why I'm subtracting, because there was a decrease. So the answer here became what? D. Reducing, definitely. Oh, we have a 20 here, it's reduced. Oh, we have a 30. 100 cannot be. You cannot reduce 80 and you get 100. So this one is completely out. So the right answer was lying in between these smaller values. However, the perfect answer was D. 1.7. 1.7 takes us back to the exponent rule. Now, this here we are using the quotient rule, whereby because we are dividing. So 25 divided by 5, you get 5. 25 divided by 5, you get 5. So x to the power 8 divided by x to the power 6, what happens? X to the power 8 minus 6. So our x has to be squared. What about the y? It's y cubed divided by y squared equals to y minus 2, which becomes what? Y. Therefore, our answer is supposed to be 5x squared times y, which is D. So the answer is this one here. Exponent rules. Also here, exponent, simplify. Simplify meaning this here we are using rule number 4, which we called power to the power. So these powers inside are the power to the 2. So meaning 6 is going to be power to the 2, then a to the power 4 to the power 2, then b to the power 7 to the power 2. The rule, what does it say? Here the 6 becomes 36, which is okay. Then the power to the power, we multiply the powers. So here becomes 8 to the power 8, 8 to the power 8, then b to the power 14. Do we have any number that looks like this? Yes, it's here. So the answer here became D. Okay, they're telling us the ratio of 200 centimeters to 1 meter is equivalent to, in simplest form. Now, remember ratios work with same units. These are centimeters, these are meters. What do? We shall take the 200 equated to, how many centimeters are in 1 meter? 100. If we cancel off these zeros, we shall see that remain with the answer as C. 2 is to 1. Gugu traveled from Soweto to Midrand at an average speed of 70 kilometers per hour. How many kilometers can she travel in 30 minutes? These are minutes. Take note of that. The speed was in hour. So what we're going to do, we shall change the minutes to hours, whereby we set 30 divided by 60, you get 0.5. These are hours. So what happens next? It will be the 70 times 0.5, which becomes 35 kilometers. Okay. Why am I multiplying and not dividing? Because I'm looking for distance. So distance equals to speed times time. When you remember that triangle very well, that's a grade 8 D S T V. So if you're looking for speed, we shall say speed equals to distance over time. If you're looking for distance, distance will equal to speed times time. Then if you're looking for time, we shall say distance divided by speed. Okay, this marks the question 1 revision. Let's look at another pattern. You see question number 2. Question number 2, here we are looking at write the number 2 times 10 to the power negative 3 in decimal format. In other words, they want you to say 2 times 1 over 10 to the power 3, which is the same as 2 over 1,000, which becomes 0.002. Convert 42% as a decimal. This will be the same as 0.42. as a decimal fraction. They want us decimal. The moment you hear decimal, they want commas. Actually, how would you have used your calculator? You'd say 42 divided by, or 42 over 100. You press equals. It gives you that much, but press this. All right. That is it. Then we go to simplify. When we say simplify, we need an answer at the end. Now, simplify the following without using a calculator. Simply meaning we need the workout. For you know very well, 2 to the power of 4. If you don't know it, you can use your calculator, but I want to see the answer you get. To the power 4, 16. So come here, show me that it's 16. Plus, remember the rule. Any number to the power 0, you get 1. So the answer here became 17. Don't just give me 17. I want to see this, and I want to see the answer. Okay, without using a calculator still. But you might not know 6 to the power 4. Come here, come to your calculator, press 6 to the power 4. What is it? You come down here, you show me. It's 1,296 divided by 6 to the power 3. That means it's going to be lower. Divided by 216. What answer do you end up having? I believe here you have the answer, what? 6. Or someone else would have said 6 divided by 6. I'm going to use the quotient rule, which simply means 6, 4 minus 3, and the answer becomes 6. You are also right when you're using exponents. Okay, we look at this. Oh, wow, these numbers they all have the same base. So here we use the product rule, which is rule number 1. Rule 1, which you say the product rule. What does it say? If you multiply the same bases, you add the powers. So the base is A, meaning 6 plus the 2 plus the 5. I'm adding the powers. And the answer became A to the power 13. A to the power of 13. That's the answer. Okay. I'm continuing question number 2.3, and we are simplifying. Simply meaning we need to get the answer. Now, how do we simplify this? This simply means you're looking for the square root of 16 over the square root of 25 times the cube root of 125, the cube root of 125 over the cube root of 8. Let's simplify that. The square root of 16, it's 4, over the square root of 25, it's 5, times the cube root of 125, it's 5, over the cube root of 8, it's 2. So now they have become normal. So which becomes 4 times 5, you get the answer as 20 over 10. So the answer here became what? 2. Simplifying to get the answer without using a calculator. If you don't know how to do this, please use the calculator, but step by step. Look for the square root of 16. Press equals. Okay, you come and write it there. Then you look for the cube root of 125 equals to 5, you see? So everything is there. What about the square root of 25? You check on your calculator and you get the right answers. But you do step by step. Don't just give us the answer only. Because this is what we mean by without using a calculator. We continue and we look at write down the numbers 120 and 200 as products of their prime factors, and then determine the highest common factor and the lowest common multiple of the two values. Now, these are two methods. What you're going to do about the factors, we can write down all the factors of 120, which is we have 1 and 120, 1 and 200. So we have 2 and 60. Here we have 2 and 100. Then we have, here we are looking at factors. We have 3 and 40. Here we have 40 and 5. Then do we have any other here? Let's see. We have 60. No, 60 is already seen. 6 and a 20. Here we have a 20 and a 10. We're looking for numbers that are straightforward. We have 8 and 15. Yet here we have 8, 25. No, the line is incomplete there. So here we look at the highest factor, the highest common factor, the biggest number that you see on top and you see below. Here we have a 60 here. We don't have anything, so 60 is out. We have a 40 and a 40. Okay. It's both on both sides, 40 so far. So there's a 20 here, but it's low. There is a 10. I believe also here we have a 10 and a 12. There's nothing. We have 8 and 8. Among these we have 40 as a common factor. Common highest what? Factor. All right, we can use this method here. And we find out now this one here has 5 times 5. Whereas here we have, so what is common in both? We have 2 to the power 3. Why do we have 2 to the power 3? We see this. It appears 3 times. And here we also have it appear 3 times. So what is common here? We have 8 times 5. And here we have also 8 times what? 5. Which brings the highest common factor. It brings it what? 40. All right. Okay, what about the LCM? What are we going to do for the LCM? Let me just show you. For the LCM, we shall combine the two of them, but still we degrade using that same factor, the ladder formula. We are going to use the ladder formula. We are not dividing what we call long division. It's not long division, but we are looking for numbers that can reduce these numbers and don't get a remainder. We use factors. All right, so what we are going to do, shall say 120. Then we put 200. So we look for numbers that we might divide this and don't get a remainder. For example, we have 10. 10 divides this and don't get a remainder. So here you remain with 12, you remain with 20. So from here we can still go ahead. We can use a 4, whereby we remain with a 3, remain with a 5. What we are remaining, so our main aim is to remain with a number that once we the number that gives us what? 1, 1. So which number divides this and don't get a remainder? So we shall start with a 3. 3 divided by 3, 1. But 5 divided by 3, it's impossible. You remain with your 5. So already this is 1. So we call it 1. Then 5 So what is the LCM? The LCM will be 10 times 4 times 3 times 5, which becomes, this is more like 40 times 3 times 5. The answer becomes 120 times 5. So the LCM is what? 600, the common lowest multiple. So the factor is 40 and the LCM is 600. That marks the end of question number 2. I'm just checking on and we see. Then we look at another question here, question number 3. This is algebraic expression. Together? So they're asking us. So this revision is a mixture of what I gave you, whereby we have whole numbers, common fractions, exponents. We shall see them as we go on. Anyway, given the expression, negative 6 times x to the power 3 plus x minus 5 to the 5x to the power 2 plus 2x to the power 4 plus 3. Write down. What do they want us to write down? They want us to write the number of terms. This is a term. This is 1. This is a term. So 2. This is a term. So we have 3. This is a term. 4. And this is a term. 5. So how many terms, number of terms, we shall say? There are 5. Then the constant term, which is this one, does not change. So the constant term is 3. The coefficient of x squared. So we look for x squared. And what's the coefficient? The coefficient carries its number. So it's a negative 5. Negative 5. Then the degree of expression, the highest degree here, it's 4, as you see it here, because this is 3, this is 4, this is 2. Then there's, in the expression, write down the expression in descending powers of x. Descending, big to small. So we shall start with 2x to the power 4 minus 6x to the power 3 minus 5x squared plus x and with the constant. Okay. Simplify the following expressions. When they talk of simplify, here, when the moment you check here, first thing we do, let's look for the like term. So far we've seen. So we have 8x minus, not plus, minus 3x squared plus 6x minus 2. So what does this become? It becomes 11x squared minus 4x. Why do we get minus? Because, sorry, it's a plus, sorry. This is a positive number affected by a negative. So, and the positive number is bigger than a negative. So you get a positive. Okay, what else? Do we see xy? We have xy here and we have a 2xy. Okay, let's collect that and we say 2xy, 2xy, 2xy minus 6xy plus 2xy minus 5y plus 3y. A number carries its head. That's why you see here you have plus 3y, yet here you have negative 5y. All right, here we have negative 6xy, because it's what? A minus. Then we continue. This is more like 10 minus 6 plus 2. 10 minus 6, you get 4. 4 plus 2, you get 6. So it's 6xy. This is negative 5 plus negative 3 plus 2, 3. So we end up having negative y, not negative 2xy, negative y. So that is it. Okay. I don't don't know whether you see this clearly. We can do it this way. Say we have 10xy minus xy, then plus xy. So they all have xy's. So pull out the numbers, which is 10 minus 6 plus 2. Put these numbers alone, and you leave what? Xy. Don't forget that this other side you had remained with your plus y minus 5y. Also these ones, since they have y, you can say put out the numbers alone and remain with your y. Now, what do you get from the first bracket? Put it in your calculator to confirm the answer. So you'll say 10 minus 6 plus 2. It's a 6, okay. So my first bracket, I have a 6. But this 6, when the bracket goes away, you remain with xy. Then 3 minus 5, this is obvious. 3 minus 5, you end up with a negative 2. So you say minus 2. So here we got a minus 2. So becoming what? Leaving you with y. That's how we do it. Okay, we come to this one here. What is common here? First and foremost, we are simplifying using the rule number 4, the power to power. So here we have 7 into x to the power 6 plus 2 into x to the power 6, which gives me 9x to the power 6. 9x to the power 6. Okay. This is the same as having the root is a half, then the cube root is a third. So remember, this is the same as us having, open brackets, 81, 6 to the power 4, then to the power half, minus 27, a to the power 9, b to the power 6 to the power a third. Where is the third coming from? It's from the cube root. Then where does a half come from? From the square root. So power to power, so square root of 81, it's 9. Then power to power, if this is a half times 6, what do you get? It's a to the power 3. Then a half into 4 to be b to the power 2 minus, if this is a third, sorry, the cube root of 27 is 3. Then we have a. A times 9 times a third, you get 9 to the power 3. Whereas b, this is 6. 6 times a third, you remain with the 2. When you look at them critically, they are the same. So we subtract the numbers normally, which gives us 6 into a cubed b squared. B squared. So 3.3. Evaluate the expression. Evaluate the expression. Simply meaning you're substituting. If x equals to 1, so what does it simply mean? It's 3 into 1 to the power 2 plus 2 into 1, then plus 4. 3 into 1 squared is the same as 3, plus 2 into 1, you remain with the 2, plus 4. So here the answer became 5 plus 3, 3 plus 2, 5, 5 plus 4, the answer becomes 9. That's what they wanted you to do. Okay. That's what they wanted you to do. Wonderful. Here we go. Simplify the following integers without using a calculator. This, all we need is a rule. So you see very well. So now here you have a plus and a negative. They multiply. So this became that much. Positive times a negative, negative 14. And the answer becomes 22. For you to confirm, put it in a calculator. 36 plus negative 14. Press equals. You have 22. You use a calculator just to confirm. Okay? So you show us this working here. And you show us the final answer. 771 minus. So these are multiplying, which will be cause what? It will cause an addition. So becomes 71 plus 23, which became 94. Don't hesitate. Use a calculator to confirm. Answers only. We might not give you any mark. Answers only. We might not give you any mark. Minus 23 becomes 94. Okay, we continue. Now there's an effect here, which will become a negative. There's another effect here, becomes a negative. This one here becomes a positive. Why do I say that? Here there's a multiplication sign. So plus times a negative, you get a negative. Here there's also another multiplication sign. A plus times a negative, you get a negative. So in other words, it's a 12 minus 8 minus 5 plus times plus, negative times a negative, you get a plus. Plus what? Plus 2. So here the mathematical formula continues, which is 12 minus 8, you get a 4. Here we had a negative plus a positive, but the negative is bigger than a 2, a positive, so you have a negative. So here the answer becomes 1. What do you do to confirm? You come here, press your calculator. 12 plus negative 8 plus negative 5 minus negative 2. The answer becomes 1. Wow, it's right. Even though you put them in brackets, it's the same story. So I hear someone there saying, what about the brackets? Put them in the brackets and you see what happens. Still get the same answer. Okay, let's look at 4.1.4. They're telling us 2 to the power 3, it's 8. If you don't know, use your calculator. All I want you to do is to simplify this step by step. So 2 to the power 3, it's 8. Then minus square root of 5. If you don't know it, use your calculator. Square root of 25, it's 5. Bring it here. Plus 3 squared. I want you to tell me 3 squared. When you use a calculator, what answer do you get? 9. You see that? So it continues. This, consider the minus and the plus or the body mass, then it's nothing much, but still. 8 minus 5, you get 3 plus 9. So the answer here became what? 12. To confirm your answer, get everything, put it in the calculator. 2 to the power 3 minus square root of 25 plus 3 squared. Answer becomes 12. Indeed. So this is what I wanted. Simplify. Don't give the answers only. Okay, we look at these functions. A function should have an input and it should have the output. All right, you ask yourself, how did they get these values? A shall say -3 squared. Why am I using -3? Because -3 is on the same level of A, but it has to first go through the process and it comes out. So -3 squared plus 1, which is the same as 10. How did I get 10? I asked myself, when I have a negative number, I square it afterwards. Afterwards, I add a 1, I get a 10. What about a B? So this is B. For B, it's a 1. So 1 squared plus 1. What do I get? I get a 2. Then this is working backwards. Working backwards, I already have my Y. So what is the value of C? The value of C will become 5 minus 1. Then I look for the square root, which is the same as 4 square root, and the answer became 2. Why am I using now the square root? Because I'm working backwards. I'm looking for the answer that gave us 5. I'm looking for the answer that gave us 9. What was the input? So here the C is 2, and the D will be square root of, open brackets, this 9 minus 1, and the square root of 9 minus square root of 8. So D is the square root of 8. D is the square root of 8. A, we said it's -3 to the power 2 plus 1. We got our answer as 9 plus 1. The answer became 10. B, we are saying 1 to the power 2 plus that, which is the same as 1 plus 1. Answer became 2. Then C, we are working backwards. We already have the answer as 5 equals to x squared plus 1. So the 1 will jump, this one comes over, it crosses the bridge. It crosses the bridge, now we have 5. When it crosses, it was a plus, becomes a minus. So it's minus that, equals to x squared. But I'm looking for the value of x only. So x squared equals to 4. I apply the square root on both sides. The square root dies with that. The answer becomes 2. Same will apply here. I already have 9 equals, we are working backwards, so it becomes 9 minus 1 equals to square root. So which is square root of equals to 8. I'm looking for the square root on both sides. This dies. So my answer becomes square root of 8. Please don't put it in decimals. Leave it the way it is. So that is there how we get the answer. Let's look at this. Determine the rule that can be used to calculate either the input or the output rule. So the input, now we ask ourselves, oh, what number? What happens to 4 to give us 9? I know very well that when I take my 4, I multiply it by 2, I get 8. But for them, they got 9. That means they added a 1. Okay. What about the 2? If I take my 2 and multiply it with 2, and I add 1, do I get 5? Yes. So the rule is input times n. Sorry, 2 times the input plus a 1. That's the rule. Or if you want the output one, sorry, from the output to the input, this one would be, this has to be output minus 1 divided by 2. So there are 2 rules, which will become y minus that will give us the input, which is x or n. Y minus 1 divided by 2. Working backwards. Yes, here, this is what we call the patterns. Patterns. Now, this is numeric or linear pattern. Geometric pattern, here we have diagrams. Okay. Here, they are saying extend the pattern with next 3 consecutive numbers after in that order. Now, when you see, this is T1, T2, T3. What's the difference? We have a 5, we have a 5, we have a 5. So, what is the next 3? What are the next 3? So, what number? When you add 5 to 20, you get 29. When you add 5 to that, you get a 34. When you add 5, you get a 39. When you look at this critical, you see that they're adding 5. So our next 3 terms are 29, 34, then 39. They're increasing by. So they're saying describe the rule in pattern in words. So we say, you can say add 5 to the previous term. Add 5 to the previous term. They said in words. That's why I'm writing in words. Then they're telling us, determine the general rule. Now, for determine the general rule, remember that our Tn equals to Dn plus B. How do we get our D? D equals to 2, term 2 minus term 1. So our term 2 here, our term 2 is 14 minus the 9. So our difference is 5. Then what about the B? The B will equal 2 term 1 minus the difference. Remember our term 1 is, this is our term 1. And this was our term 2. So term 1 is 9. So we shall come here and say 9 minus 5. So our B is 4. Good to go. So our Tn is complete now. We shall say our D, we got it as 5, n, then plus 4. Plus 4, where n is the position of the term. Position of the term. Okay. So use the general rule term to calculate the 20th term. So simple now. This means our T, our N has become 20. So we said, remember, plus 4. So here the answer became what? 100 plus 4. So the final answer becomes 104. 104. Calculate the position of the term N. If the Tn is 304, we are looking for the position. So simply meaning our Tn already is, remember we said our Tn is 5n plus 4. So now they've told us our Tn is 304. What was the position? We don't know the n. So guess what happens? The 4 crosses over. When the 4 crosses over, becomes a negative. That means it has crossed over. So what are you left with on the left-hand side, on the right-hand side, we are left with 5n. So 5n equals to 300. I'm interested in n, so what do? I divide through by 5. I divide through by 5. This goes with that. So my n becomes 60. So the position is 60. Patterns. Okay, when you look at, or when you hear, when you look at what we call the patterns, please, the general rule has to be in your head. Know how to interpret, know how to get these values here. This has to be in your head. This, you have to remember this. You have to remember. You have to remember this, how to get the values there. Okay, there we go. Question number 6, simplify the following. This was done in term 1, but just know, when we are dealing with fractions, if they have the same denominator, just deal with the upper one. So this will become over 7, because the same denominator, then 5 minus 3, which becomes 2 over 7. This also happens when we are dealing with addition. Okay, so division. Division, this other fraction, the division sign becomes a multiplication, and this other sign reciprocate, it turns upside down. All right, so this means it becomes 3 over 4. The division sign changes, and what was a denominator in the next fraction becomes a numerator, and the numerator becomes a denominator. So in this case, you have 6 over 12, which is the same as 1 over 2. So the numbers had to reciprocate. Okay. So this became, another person who sees this nicely, you can see that you remain with 2 over 4, which is the same again. Okay, that's what we call by dividing. Now, here we are multiplying, but we have one side, we have what we call the improper fraction, sorry, we call it a mixed fraction that causes an improper fraction. So this is called a mixed what? A mixed fraction. How does it become a proper fraction? What are we going to do? We shall say 2 times 5 plus 2 over 5. I'm changing this to a improper fraction. So meaning 10 plus 2, which is what? Over 5. So good to go. So my fraction has become 12 over 5 times 5 over 2. When we look at it critically, this goes with that. You remain with the 12 divided by 2. The answer becomes 6. The answer becomes 6. That's what happens when we are dealing with simplifying fractions. Anyway, let's complete also this. Now, when you look at this, these are all mixed fractions. But take note of these symbols here. First and foremost, turn them into improper fraction. That means 2 is going to multiply with the 6 plus 1. So 2 times 6, 12, plus 1, you have 13 over 12. Divided by, I'm still changing the mixed fractions into improper fractions. So 3 times 4 plus 1. So 3 times 4 plus 1, what do you get? You get 4 times 3, you get 12 plus 1, 13 over 4 times, change this, 2 times 2, 4 plus 1, 5 over 2. So what happens first? This is going to change if you to look at division. So it's going to be 13 over 2 times 4 over 13. Why am I changing like this? Because the division sign turns into a multiplication. Then the multiplication remains. Now everything is multiplication. What do we do? You can simplify or leave it the way it is. Now, when you look at it critically, anyway, let's simplify. Because when you look at it critically, this 13 will die with that since you multiply. The 2 will die with this, you remain with the 2. And this 2 will die with that, you remain with the 1. So simple comes what? 5. Or if you don't want to do it that way, you can do it this way. And you'll use a calculator to confirm your answer at the end. So this one we said it's 13 over 2 times. Why am I multiplying? Because the division sign has changed. Then the 4 will go up, the 13 will remain down, times 5 over 2. So since it's multiplication, we multiply the numerators alone and multiply the denominators alone. So simply meaning, we are going to say 2 times 13 times 2, which is 13 times 4 times 5. So on top, what we end up having, come with the calculator here, 13 times 4 times 5. You have 260. Divided by, what do we have at the bottom? 4 times 13, I believe is a 72. 2 times 13 times 2, 52. So get this into a calculator. 260 divided by 52. The answer becomes what? 5. The answer becomes 5. For those ones who had seen it already, this 13 would go with this. They disappear. Then the 2 here divides with that. You remain with the 2. And again, this 2 here divides that 2. You remain with the 1. So whereby you remain with 1 times 5. So the final answer becomes 5. Either way, you still get the same answer. Now, increase 156 in a ratio of 2:7. Now, the moment you hear increase and you're dealing with ratios, this simply means you'll use a bigger number. So the bigger number goes on top of a smaller number. Then you multiply the number that you are dealing with. So that is it. Simply meaning the number is going to increase by 3.5 times. So here the answer became 500. By the way, the moment you hear increase, that means this number has to go up. Should you get a lower number, just know your answer is wrong. Just know the answer is wrong. Okay, we look at question number 7. This one needs a little bit of your understanding, but we shall go through it. Now, the person called Sophia needs to purchase 10 kg of rice and has 2 options. Option number 1, she buys a 10 kg bag straight away, but look at the cost. Then, she has another option of buying 5 2 kgs. Remember, her aim is to get what? But each kg costs how much? 28. So they're asking you which option will be the best for Sophie and why. Give a reason for your answer. Let's look here. Already this is 10. This is it. But what about if you buy 5 of them? So meaning it'll be 5 times 28. So here, you have to get the answer this much. That means you say she has to buy 10 kg because it's what? It is cheaper. Or you can say she will save she will save what? 21 rands 96 cents. Okay, so 7, it asks, the price of 2-liter cooking oil in South Africa increased from 79.99 to 99 rands 99 cents last month. Calculate the percentage increase. The moment you hear percentage increase, it will be the new value minus the old value divided by the old value times 100. We are looking for percentage change. So the reason why we are multiplying by 100 is because we are looking for percentage change. Percentage change so here we shall say our new value is 19.99 rands. The old value is 79.99 rands. Divide by the old value, then multiply by 100. We are looking for percentage change. Percentage change. So we get the difference there. I believe it was 20. Get the difference there. 99 minus 20. So what do we do? Step number 2 shall say 20 over 79.99 times 100. And the answer became the answer is 25%. 25%. Here we go. Sharing in ratios. When you take note of that, there are 3 boys of a certain family went to school weekend trip. They were given 3,500 to share from the youngest to the oldest. That means there are 3 people, youngest to the oldest. That means there are 3. So we shall say yeah. Then we have the middle one and the oldest. So the youngest had to take 2 parts, the middle one had to take 3 parts, and the oldest had to take 5 parts of it. So calculate how much each boy will get respectively. So what do you do first? Since they are ratios, what do? We get the total ratio. When you add everything, what do you end up having? We have 10. So simply meaning out of 10, the youngest gets 2 out of 10 times the money they are to share. Then the middle person, the second thing becomes times the money they are going to share. Then the oldest gets 5 over 10 times the money they are going to share. So when you use your calculators there to get a perfect answer, this one becomes 700. The first one takes 700. Then the next one takes 1,000. 50. Then the last one takes a half of it, which is 1,750. Another method would have been we get the total unit ratio. We get a total unit ratio. This is method 2. So we get the money that they are going to share. We divide it by the total ratio. So here it becomes everyone's standard is going to get that much. So meaning the youngest is going to get 2 times 350. The middle person gets 3 times 350. Then the last one gets 5 times 350. Still, you get the same answers. That's another method. Okay, this was revision 1. We shall look at revision 2 tomorrow.